Deborah, how are you?
Hi, thank you so much for having me.
Yeah, we're delighted to have you with us here today, and we're excited to get to know a bit more about you. So, I have 5 questions for you today, and
Okay.
we're going to try and do this in about 5 minutes. But do you know what? If we go for 5 minutes, that's fine. So, are you ready?
I'm ready.
Excellent. So, the first question that we'd like to ask you was the most popular question asked by our staff members is what are the top 3 things about working at Yale?
Let's see. It's going to be like real estate. Except instead of location, 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 it's students, students, students.
Oh,
The undergraduate students here are amazing. They are, they're just the best students from the United States. But I work with the admissions office because I've been so intrigued at how it is that Yale gets these students who are not just brilliant, but they're also just really nice and resourceful and kind and supportive of each other. So it's just so much fun to work with them and see them move along. I mean, the department and the university is also incredibly supportive of research. So that's
mm-hmm.
another big thing. And then being the location is actually not so great. We're in New Haven, Connecticut, which is sort of a small town. I
Mm-hmm.
moved here in 2010 from San Francisco, California. So it was a huge shift to move to a small town, but
Yes.
train right away from New York or Boston. So yeah,
Oh, that's not too bad at all. That sounds
that's
lovely. Our next question for you is what is your proudest achievement to date?
mm. The proudest achievement is definitely the latest one.
Hmm.
So my team just finished building an instrument which is called Express. That's an acronym for the Extreme Precision Spectrograph. We just took a few letters here and there to make up that name.
Hmm.
And this really represents the culmination of the last 20 years of my career, trying to figure out how we're going to detect Earth-like planets around other stars. And we designed and built the spectrograph in the lab at Yale. And we're running short on funds and running out of time. And so at the very end of the project, I ended up driving the instrument in a U-Haul truck across the country
Oh
with
my
my
goodness.
son. We made 2 trips across the country, and the team flew there and met us, and we handed off. But the instrument is delivering precision that's really record breaking. So
Oh,
I'm
exciting.
incredibly proud of that, and gives us a chance to really detect small rocky planets that could be in the habitable zones of their host stars.
Oh, that sounds very exciting, and that is definitely a great achievement. So, congratulations on that, Deborah.
Thank you.
Brilliant. The next question for you, then, just talking about exoplanets, is what are the most common types of exoplanets found around stars?
Yeah, we might not know the answer to that question yet. And that's because all of the methods that we use to detect exoplanets have some observational bias. It's as if you're looking out the window of your house. You can only see the things that are straight ahead of you.
Hmm.
So with the method that I use with spectrographs, we've in the past only been able to detect very large signals because the spectrographs just weren't that accurate and
Right.
our methods weren't as sophisticated. And with the transit technique, where the planet crosses the face of the host star and dims out some of the light, that technique has its own set of biases. It's best at detecting planets that are very close, that orbit very close to the host star.
Hmm.
It could be that planets that are like the Earth are ubiquitous, and we just don't know yet because we haven't been able to reach that part of parameter space in terms of the
Hmm.
mass and orbital period.
Right, that's so insightful. I mean, I wouldn't have thought there was these types of biases, but there you go. I've definitely learned something new here today myself. The next question then to do with Earth-type planets is what do you need to look for when searching for Earth-type planets?
Yeah, great question. Something that's sort of I've been obsessed with my whole career. And I think the best we can do right now is to try to find planets that have a mass and maybe a radius that's similar to the Earth and that orbit at a distance from their host stars where it's not too hot, not too cold. So liquid water could persist in, pools, oceans, rivers on the surface of the planet. Those are the conditions I mean, those are the observables,
Mm-hmm.
orbital period or distance from the star, and mass or radius of the star. Those are the parameters that we can observe, and we can't do much more right now.
Mm-hmm.
But those, if we can find, let's say 100 of those types of worlds, then that sample, I think, will be enriched for planets that host life.
Excellent. And so you were talking about your proudest achievement being the latest thing that you've been working on. So I can't believe you had to drive an instrument in a U-Haul all the way across the country. But my final question for you, Deborah, is what are you currently working on then? What is next for you?
Yeah. So right now the instrument is just commissioned, and we're starting a survey to try to find Earth-like worlds. In fact, our project is called the 100 Earths, the search for 100 Earths.
Mm-hmm.
But in addition, there are space missions that have flown, and we're trying to provide follow-up support. So for missions like Kepler or TESS or Corot or Cheops that the European Union has just launched, if you can measure the size of the planet from a transit, and we can measure the mass of the planet with radial velocities with our spectrograph, we can combine these two methods and measure a bulk density. Mass divided by volume will give you a bulk density for the planet, and we can begin to understand the characteristics, the attributes of those planets. In addition, I've been working for the last 4 years serving as a chair for a NASA committee to try to figure out what the next big mission will be. It will be beyond my career, because this is a mission that won't be launched until the late 2030s or probably 2040s. My team of international astronomers, so both US, European astronomers from Asia, from South America, all came together to try to define a project and instruments that could detect biosignatures, signatures of life in the atmospheres of small rocky planets. So what we're doing right now with the 100 Earths project, I feel, is to get the names, addresses, the phone numbers of the planets that are most likely to harbor life, so that one of these future missions will be able to stare at the atmospheres, find out if there are things like methane and oxygen, which might be indicators of life on those planets.
That just sounds so fascinating. And Deborah, I want to thank you so much for taking the time to chat with us today. I know everyone in the Armagh Observatory and Planetarium are eager to listen to this interview. So again, thanks everyone at home for joining us. I hope you've enjoyed talking with Debra Fischer today as much as I have. And again, thank you so much, Professor, and we will hopefully talk to you soon. Thank you.
My pleasure.